All right. Hello, everyone. And as you already heard, I'll be talking about modeling the environment from the sun to Earth. Can you hear me, by the way? Yeah. Okay. Or speak up if you cannot hear me. So at the beginning, I would like to walk you through it exactly what I'll be talking about, because as I could hear the other lectures and also talk to some people, I see that this is a bit farther away than mostly what you work on. So at the beginning, I'll give a bit of a background. I'll give a bit of a introduction of what is space weather, what causes it and the effects, and then what we're doing to in order to mitigate the damage coming from it. So what kind of models are available out there, and I will very briefly introduce what these models are to have an idea what is happening behind these models. And then I'll introduce the Virtual Space Weather Modeling Center, which is the United European Effort for Integrated Space Weather Modeling. And I'll show a demo how to use it, how to find it, and how to do different type of simulations. And then I'll finish with some outlook and some further developments that are planned. So let's start at the beginning. What is space weather? I believe that most of you have already heard and know it, but space weather describes the variations in the space environment from sun to Earth, with a big and specific emphasis on the surroundings of Earth. It basically consists, so the area between the sun and the Earth consists majorly is filled with solar wind, which are the particles that leave the solar surface and propagate outwards. Usually these are generally low energy particles, and the solar wind has this feature of bimodality, so it has slow and fast streams. And then the main driver of space weather and the disturbances in space weather are coronal mass ejections, and further on I'll just call them CMEs because it's just too long. And this is the sudden release of plasma of the magnetized cloud. You can also call from the solar surface, and they are highly energized, and they propagate in the heliosphere, so that they can reach the planets and propagate even further. And then also solar energetic particles play a very important role. These are very fast particles that get accelerated either low in corona because of solar flares, or they can get accelerated along their propagation with the interaction with the shocks of CMEs or correlated interaction regions. Then just the space weather is very important indeed. And now that I was just looking and hearing all different talks and all this different perspective, I was thinking it would be really interesting if we would really quickly do this poll. So if you could just get your phone and scan the code, but let's do it really quickly, not to spend too much time on it, because then we will get the cloud of words. What can be, I mean, what you think is affected by space weather? Because yeah, we can be talking about all these models, how important they are, like that we try to improve them, but why? Because we know that a lot of money is being spent on it. So then we need to know that it is important enough that it's worth it to spend all our money and time. So well, not only students, I mean, everybody can do it. It's just an idea. What already there was kind of a hint in the previous slide. What is affected space weather, like, or how much money does it cost every year, these space weather effects? I'll just give 2 minutes maybe, so that you can just put in, you can put several answers. You can put one word, or you can put one answer or several at the same time, and that will appear here interactively. So the Earth, yeah, it does definitely affect the Earth. It affects the whole solar system, exactly. So whenever some eruption is not directed to Earth, yeah, okay, we're not affected at the time and we're not struggling. But someday, when we have some communication satellites around, it will be quite important. So we have communications. Yes, that's true. It affects telecommunications. I see GNSS billions, and I understand that it costs billions and it affects the GNSS systems, and that both are very true. Phone users, yes, because of GPS. Electrical grids, yes, indeed. Aircraft, Yeah, exactly. We can be affected as well when we just want to fly from one place to another. Satellite operators, everyone. Yes. Okay. So we are in the LEO satellite, very specific, but I guess yes. So we are very well aware of how much it affects. And then I was also wondering just to see how much we care about space weather, because usually everybody checks like space, just weather forecast every day, right? And then I was just wondering who cares about space weather, because I went to Google just to search for it, and I was expecting just some ANA papers or some space weather papers from scientists, but on the first page, surprisingly, it were just paper and just articles from journalists. And it turns out that some of the Midwestern farmers really struggle a lot because of space weather effect, because the GPS satellites fail. And if that coincides with the cropping period, then they really struggle. Then I also get a lot of reports from the estimation of economic loss from the US government, for example, or different. And they have estimated that it costs about 40 billion, some of the events, not everything costs $40 billion every day. And of course, the Great Quebec blackout. So the power grid failed just because there was a very, very strong CME that hit Earth, and there was a power blackout for 9 hours. So just people minding their own business, sitting in front of TV, they just couldn't do anything. So indeed, this affects everything and everyone from sun to Earth. So that is why it is so important to learn these effects, to model these effects, and to be able to mitigate them. So here is a very, very nice compilation of all ongoing different missions. Some of them contribute to improving the forecast. Some of them are the satellite missions, which are also very important. But you can see that apart from only Earth, also a lot of other things can be affected. And as our dependence really grows on technology, this problem is emerging more and more. So it's becoming more and more important. So this is one example. When I was preparing, I was looking at, because there was one Carrington event that happened in 1859, and if you haven't heard about it, it was just a very, very severe storm. And if that would happen today, it was estimated that it would cost $2.7 trillion to recover, and about 6 to 8 years. So that is huge amount. And as I said, it's growing. So our dependence is growing. And I just really love this quote from the paper back then, how they reported this problem. The colorful displays were so bright that people in Missouri could read by the atmospheric line after midnight. So while they were just mistaken, and they thought that the sun rose, today it would just cost trillions of money, and a lot of it could be even affected by death because of some ambulances that would fail or so on. So with this, I wanted to make sure that we agree and we understand that we really need fast simulations. We need to be able to mitigate this problem. So for that, we definitely need to have improved, very fast and efficient space weather forecasting tools. With this, I would like to introduce EUHFORIA, which was recently developed at Center of Mathematical Plasma Astrophysics, Leuven, and it is a European heliospheric forecasting information asset. It is similar to NLIL, what is the US initiative, but this EUHFORIA is the European tool for space weather modeling. So here at the beginning, I would like to go through what EUHFORIA exactly is and how it performs these simulations and how it enables forecasting. So of course, as any model, it needs some input, it needs some knowledge, it needs some information that we're actually modeling the sun and not something else. So because of this, we start at the solar surface. So we take the magnetogram, observed magnetogram at the solar surface, which is used for the input of the first chain in this forecasting tool. So then we use this magnetogram, observed magnetogram of the solar conditions to put into the coronal model. And currently of EUHFORIA, still the default coronal model is the WSA, Wang-Shiliarge semi-empirical model, which is really fast because it's not totally physics-based. Then This coronal model covers the domain from the solar surface to 21.5 solar radius. So the main task of this model is to provide the boundary conditions for plasma variables at 21.5 solar radius that can be used later for onset of the heliospheric part. But on top of it, on top of this, in parallel, if we want to propagate some CMEs and model the CMEs, then we would need to look at coronagraphs, and we would need to fit some CME models and estimate the parameters so that we can input and inject some CMEs in the heliospheric domain. And here comes the biggest and the heaviest and the most expensive part of space weather modeling. It's the heliospheric domain. It can run with EUHFORIA original heliospheric domain, but recently we are also working with the newly developed alternative heliospheric model Icarus. But both of them serve the same purpose. So this domain covers the part from 21.5 solar radii to 430 solar radius. So this is from 0.1 AU to 2 AU. So it includes the orbit of Mercury, or orbit of Earth, of course, also including Mars. The outer boundary can be changed, but by default, it's run up to 2 AU. And after this modeling is done, we obtain the 3D data of the modeled heliosphere, and we also obtain the variations at different locations. So at the different satellites or different planets, depends which ones we wanted. Then I would like to very briefly just to tell you about what different models exist and what are different opportunities to be used alternatively in this forecasting chain. So there are several coronal models that can be used and can be already used in EUHFORIA for forecasting. So the original one is the 1 Chiliard model, which is probably the most commonly used. It is a semi-empirical model. It uses the potential field source surface approximation up until 2.5 solar radius, and then it uses the Shannon current sheet to obtain realistic magnetic field and also other empirical relations to get the temperature, number, density, and velocity, which are necessary for driving the heliosphere. There is also WindPredict, which was also quite recently developed, but it is a more advanced tool. It does MHD modeling for obtaining the realistic solar wind. It has ad hoc heating and also alpha and wave turbulence heating implemented to get the realistic plasma conditions. Therefore, it is much heavier than the WSA model. And the third available one is MultiVP, which is also really fast, but is advanced a bit. It's more advanced because it's still physics-based. It calculates the largest sample of wind profiles following open magnetic field lines. So its simulation is effectively 1D, but then it's assembled in 3D so that the whole domain is covered. So these are different options. So the first one can be run even on your computer. The second one is quite heavy, and you would definitely need some architecture HPC to run that. And the third one is also, I think, heavier than your computer, but it's fast on HPC, I would say so. And then let's go to heliospheric models, because still these are the data that we're analyzing and using further. I will first describe the EUHFORIA heliospheric model, because that is still most commonly known and used and is operational currently. It models solar wind from 0.1 AU to 2 AU, as I showed, and then it solves ideal MHD equations. So this part is physics-based, so it solves ideal MHD equations with polytropic index of 1.5. It provides then 3D data and time series at different satellites, so planets and satellites. It uses HEQ coordinates, which means that the Sun-Earth line is fixed, and it uses the equidistant grid in the simulations, and it is implemented in Python C++ libraries. Then I also introduced the second one, which we have recently developed, and we're integrating in the Virtual Space Weather Modeling Center to make it also operational. It was developed at CMPA, and it also, so in the green, I showed the features that are similar to these two, and in red, I show the ones that are different, which I guess you already noticed, but still. So it's again from 0.1 AU to 2 AU, ideal MHD equations, and we obtain the similar output. But the difference and the advantage and why we started to develop it and we're using it is that we use the Tinatin coordinate frame, which means that after certain phase passes in the simulation, the wind is steady, so the solar wind is not moving anymore. Then we have the ability to fix and to modify the grid, which improves the optimization of the simulations drastically. So we have stretch grid and different adaptive mesh refinement criteria that makes the simulations much more efficient. And it is implemented in MPI MRBAC. So I state that because it's not an update, because it's implemented in a totally different environment. Then I will go now to some geomagnetic indices that the output of EUHFORIA is used to calculate, which I guess is more close to work of some of you that as I could hear. So with this output, then this code, EUHFORIA, can be coupled to the codes that calculate the geomagnetic indices. So we can get the KP index, which studies solar particle radiation by its magnetic effects, and it is used to characterize the geomagnetic storms. So it usually quantifies disturbances in the horizontal component of Earth's magnetic field, and it is given with an integer in a range of 0 to 9. And from 1 to 5, it's considered that the conditions are quite calm, but after that, it becomes quite disturbed. And here you see the typical output of the simulation that you run. This is the kind of output you get. On the x-axis, you have the date, and on y-axis, you have the particular index that you're looking for. Then at the end of the run, you can also get the DST index, which also quantifies and measures geomagnetic activity, and it's given in nanoteslas and is based on average value of horizontal component of the Earth magnetic field. And the magnetopause standoff distance model. So usually these three indices are performed together. And a magnetopause, as you all know, is the boundary between magnetic field of the planet and the solar wind. So this gives the distance where it was observed from the Earth. And this is also the typical output of the simulations. Then, how do we actually use all these different models? Because when I'm talking about it, and I already mentioned that these are separate models, so these are different models that can be run in chain or separately, but then it requires additional knowledge to be able to identify what input each of these codes takes, what output each of this code provides, in what coordinates. There are way too many parameters and ambiguities that can be associated with all of them. So here comes the Virtual Space Weather Modeling Center, which is the European effort kind of to provide the united, and not the united, but integrated space weather modeling tool. So just I would like to stress again why this was why there was such huge need for this, and also you will see how everything is connected to each other in the demo that I'll show for this tool. So, of course, this was very important because the topic is quite, so to call hot, because also we're almost in the solar maximum, or will be soon in the solar maximum. The activity is increasing, and it is very important to be able to model events. So because of that, it's very important to have this integrated space weather model frameworks, because one code cannot do anything. Because of that, and we need the predictions to be timely and accurate, and also because some of the models, as I said, can be run on your computer, but some is just impossible. It will take a month or even 2. So it just doesn't make any sense if you don't have any architecture or any cluster where you would run it. And also because of these models are so different, all doing different things, it becomes necessary to have the user-friendly GUI, because otherwise one person cannot be expert on all of the codes, or it would take just way too long to make it usable. And Virtual Space Weather Modeling Center is this also guarantees and provides the standard environment for model and data repository. So the data are stored there and also the models are integrated. And with this, you have a guarantee that the models that are integrated there are verified and validated. And it enables coupling of different models in many different interesting ways. Also, what is very important, very interesting, is that this Virtual Space Weather Modeling Center is kind of also European analog to CCMC, which is Community Coordinated Modeling Center in the US. But it is also different in some ways. So it is end-to-end, so it provides space weather modeling from sun to earth. It allows you to do simulations interactively, and you can couple different space weather models. But also, these models are distributed also geographically, which is different from CCMC. So whenever you have a model that you want to integrate or use in chain with different models, you don't have to go somewhere and install it there. So these different models are installed locally where they are running, and Virtual Space Weather Modeling Center provides the service that it connects these different models, so takes the output and manages the communication between these two models. Therefore, it does quite big work for the scientists or people who just need to use the data and don't want to do anything behind it. Also, just to stress out, is that ESA Space Weather Modeling Center provides the services to different type of service domains, starting from spacecraft design and launch operations to some non-space system operations and just general data services. So it is so its applications are quite wide. And here is just a very brief history, because in the implementation and the development of this Space Weather Modeling Center has been ongoing from 2012, so it has gone already different parts. And currently it is already focused, because it's operational, so everybody can use it, and it is just focused on improving the models themselves, keeping the most updated versions, and to have the better couplings and better chains available. This was the first time it became operational, and I suppose if you already made the account, you already came across such an interface where you can run and you can interact with this tool of EUHFORIA from it. And here are also, if you're interested, and you can also follow up, because I'll give the references, that the important part about this center is that all the codes that are available are remaining up to date, because the modelers are working with the architecture designers, I guess that's how it's called, to have the most recent versions of the codes integrated in the Virtual Space Weather Modeling Center. And the new ones are also being added, and the different chains are being tested so that it's the easiest for the user to use different type of couplings. And here is just the list of different models that are being added, and I will not go through them very in details, but you can see that these two are new global coronal models. Then we have these couple thermosphere, ionosphere, plasmasphere models. Also new the model for geomagnetic indices, KP and DST, and magnetosphere models. But also on this slide, you can see that all these codes are installed and running at different places. So it does indeed integrate the models from where they are running, which makes it more comfortable for the modelers as well, because they can fix if there is some bug more easier, and is in a way sustainable, that you don't have to install everything everywhere. So this is the overview of Virtual Space Weather Modeling Center. So you see that there are 17 codes, several tools that are already operational, and 5 of them are being integrating as we speak. So they will also become operational and available to users. And here it's just written in a way so that you see what type of coronal models are available: heliospheric models, SCP models, or the magnetosphere and more inner magnetosphere models that you can access, that you can have access to. Then let's go to a short demo, because it's I think that so far everybody should have the account, so even if you don't do the group activity with me, you will still be able to use it, and especially after the presentation, I think it will be even more clear. But here is a brief demo how you can log in and how you can use the different models. So let's start. So at the beginning, I suppose you already have seen this interface. You get the login page with the user and password, and then you log in, and this is what comes up in the full size mode if you put the website. Then one very important tool, and that is very important to be able to use, is the help, because it indeed is very helpful. So it gives the background about all the different models, and it also gives the instructions how to use Virtual Space Weather Modeling Center. So you can press on each model or in the model of your interest. So here, let's go to EUHFORIA Heliosphere, and it will pop up, and the model description will pop up with the model access and run information and the type of input and output can get. You can scroll, because here already are more models than it can be fitted in on this page, and then you can select another code, as I mentioned, another coronal mode, coronal modeling code, and also it gives the information about it. And if it's just too long, you can just scroll down, as you would see, and just get all the details about all type of physics that is going on in there, or that you might need during the simulations. Then let's go and actually submit a new run. So here, if you press on new run, you get this type of window with all different models available. So first, it's important to know that if you click behind the model, it gives the short model description. So you see that particular model chain, what type of tool, what type of codes it involves, and how it's coupled, and it's in which order. Then here is one very long chain, and again you will see in details what each of these models are. And here is the EUHFORIA Heliosphere plus indices model, which is one of the most popular ones currently. Then, if we want to do the simulation, we need to click exactly on the blue part, so on EUHFORIA plus indices, and it will take you to the input, so parameter page of the code. Here, first, you need to give the magnetogram, as I said at the beginning, because that is where we start solar space weather modeling. Here we choose the magnetogram that we want to use. So in the first field, you can see what type of magnetograms are available for this model. You choose one, and you search, because you choose on a date with particular time. So then you choose the one that you're interested in, mark it, and press select. So then you can see that your chosen magnetogram is selected, and that will be used for the input for your simulation. Then we can scroll all the way down and do the simulation, but of course this will not include any CMEs in it. So first, let's also choose CMEs to demonstrate how they can be added to Heliosphere. Here is the CME choice window that pops up. So if you press on the data provider, it shows you the catalogs which are available. Then you choose the catalog that you're interested in, and you already have chosen the date there. And then it gives you all the CMEs that happened during this date. If you press on top, if you mark that box, then you get all the CMEs, and you can add all these CMEs to your simulation. So as you can see, all the simulations are added, but you can change the parameters very easily, because maybe you're interested in studying of the CME and varying its speed or its size. So you can just go to the particular parameter, you can modify it, save it. You can also delete the CMEs or manually add the CMEs with the parameters that you have identified. Then we can scroll all the way down, and we can start the simulation. So this is the log screen that comes up after you submit the simulation, but don't get scared. It's not necessary to keep it running. It is the log screen that shows you all the details of how, which order the tools are being executed, how long each of them takes if you want to know. And you can see on the left that this simulation is still running because it is orange here, and you can just close this window as well because you can already always access it from your account. So there is no need to sit there. You don't need to have your connection always on, and you don't need to have your computer turned on, which usually is quite sometimes a big problem during modeling. Then if we go to our run history, we can see that the simulation that submitted was still running, but we can already check the simulation that was done before to see how the results section and how what you get after you do your simulation. So the first tab is the parameters, which is really very important to know to be able to always retrieve what you got results for. Then you, of course, also have the log screen if you want to go and check how long each part of your simulation took for further purposes, just to know. And then you can go to the results section where all your results are accumulated together. You can download all these different parameters that the output of these models individually, or you can download them all at the same time if you want to have different simulation results together. You can also just visualize the results already on the platform. So, for example, this is how the magnetopause standoff distance prediction from EUHFORIA outputs at Earth looks like. So this is a typical output that you get. And then you can go and see the movies of the number density or the speed in the heliosphere. If you press on play, it plays the slideshows, so you can see it as a movie as the solar wind conditions change. And then you can go back and start another simulation. For that, and also just to be able to use it very effectively, you can also just look for the model name that you're interested in, and then it will give all the models or chains that include this model. In this case, I searched EUHFORIA, and all the different models that include EUHFORIA popped up. Or you can also filter it by different models. So if you want, for example, to have EUHFORIA heliosphere and geoeffective DSO index to be calculated, you can mark both, and you will get all the chains that are available containing these different models. So then on the left, you have the overview of your simulations, and the ones that are orange are running, the ones that are green are done, and these numbers on the right show how many of these simulations you have done. So this is the brief demo of how to use Virtual Space Weather Modeling Center, which I think is quite intuitive and quite easy to use to find the information. So also the background about the model, and also how to actually apply, how to actually do the simulation and use it in different chains. Then, as you could now see what I was talking about before, that it is so hard because there are so many models, all use different inputs and different outputs to be able that you, as a non-developer for all of these codes, to be able to run them on your own or even to have access to that. It is because of that is that I'm stressing out maybe a bit too much, but that is the new trend in space weather modeling, and also, as you could see from the introductions of the eScience Center, that you need to have this platform where you have all these different models integrated and coupled for you, otherwise it's just becoming impossible. So this has been a new trend for a while to integrate all these models in one platform to be able to get better predictions, but also to be able to improve science, so improve physics that you are learning. So this type of platform, like Virtual Space Weather Modeling Center, actually enables better predictions. Because, for example, when you do the multi-VP corona plus EUHFORIA heliosphere, you get better capturing of high-speed streams compared to the original WSA EUHFORIA chain. That was default, and that is the kind of K-Leuven product. So, or if you use the EUHFORIA and Paradise, which is the solar energetic particle tool, you can use the EUHFORIA simulated interplanetary magnetic field instead of Parker spiral, and you get much better results. So with these different possibilities, you actually get better predictions. And then also, it is used to actually understand if the storm is, if the geoeffective storm is going to occur soon or not, because recently they have started using this in the real-time observations with the synthetic simulated data of EUHFORIA ETL1 to be able to predict the different geomagnetic indices. So with this way, you can have the forecast, or well, more of a nowcast of 2 or 3 days in advance rather than after the event happened. Here are several examples that I'm going to show, but after the demo, I believe that you can also just go on and find each of these simulations and each of these tools, what they are doing and how they are coupled. But one important thing is that it is operational, which also means that every day a certain chain is executed by itself. So it's not necessary that you do this run if you just need to know the conditions of that day, of the solar wind and the magnetic field of Earth, because every day this run is executed and you can access to the data. So here you see a very big chain that uses the EUHFORIA corona, EUHFORIA heliosphere. Then we go on and calculate some geoeffect indices. We also use the magnetospheric model and then also other thermospheric and ionospheric models. This, I believe, so far is the largest chain that is available in Virtual Space Weather Modeling Center, containing of 10 models, and all of them run in parallel or after each other, so that it's performed in the most efficient and effective way. And this is the most popular chain that is used in EUHFORIA with the command line, which calculates the heliosphere by EUHFORIA and also geoeffect indices. One other thing that I would like to pay some attention to is that the Virtual Space Weather Modeling Center is also available with command line. So depending what is your purpose and what type of simulations you're doing, you can sometimes it is more useful and easy to use the command line. So you can install the package for Virtual Space Weather Modeling Center, and after that you can provide your username and your password, as I showed at the interface, at the login interface. You can also have all the possibilities that can be done via GUI. So you can list the available simulations. You can start a run and give the parameter file, so identify all the parameters that you're interested in. You can use the input parameters. So here is just the comparison, how it looks like in the GUI and in command line. And you can list the available runs that have already been done, and then also fetch the results. So you can check the status of the run, whether it's finished or not. And then with the ID, you can print the logs, get to list all the results, and also, of course, copy the results if you want to analyze them. And with the Virtual Space Weather Modeling Center application programming interface can be done with this script. So here in particular, this person, David Burns, has carried out runs from Enlil and EUHFORIA for, I think, a year or even more, and he was comparing the performance of the codes. So this script particularly performs and uses the same input for both files. So it can be generated if you have to do some runs, especially daily. Then it becomes indeed more easy to do the command line. So at the end, I would also like to mention and stress out some new models that are being integrated, especially the K-Leuven models that we are very extensively involved. So the first model is the Coconut model. It is a very advanced global MHD coronal model, and this is the field modeled by Coconut, which coincides quite well with the observed data, and we are very proud of it. because, and also it's important to know that such codes, it's just impossible to do it on your computer or on very limited resources. The second one is Icarus, which is alternative to heliospheric model. And as I showed, we have a very flexible grid. As you can see here, we have grid stretching applied so that the cells are not so small. We have adaptive mesh refinement applied to the domain so that only the place where it is important is refined to high resolution. Therefore, this code, so the heliospheric code of Icarus, performs more efficiently than the original one. That's why we are developing it at K Leuven. And the last one is the Paradise, the solar energetic particle acceleration and transport code. The typical output is shown here, which uses the EUHFORIA as background wind and also then CME evolution instead of the Parker spiral. So all these models are being integrated and added to Virtual Space Weather Modeling Center to have the most upgraded products that we are providing at K Leuven and also at other places. So here is the kind of the overview slide that I would like to show. So far, what is most commonly there and what is available when you want to do space weather modeling on Virtual Space Weather Modeling Center is this EUHFORIA Corona, which is the WSA model, the EUHFORIA Heliosphere with only cone CMEs, not more magnetized or more complex CMEs that we're developing at K Leuven. And then we have the visualization of EUHFORIA, which gives the plots for equatorial and meridional cuts and the time profiles at 1 AU. But we are upgrading all of those, and it is also being integrated in a Virtual Space Weather Modeling Center. So Icarus would, in this diagram, fall here. So as alternative to EUHFORIA, which uses the same inputs from the coronal model, so that no extra work or no extra coupling is done there. And then this can also be visualized in the same way, therefore obtain the equatorial and meridional cuts and time profiles at 1 AU. Also, it is being added to provide the time series plots, so varying plasma conditions in comparison to observed data, because usually when you are a modeler or you need to get some input, you still need to compare it to observed data. Then the coronal model alternative one is also being integrated. So coconut would go here in this diagram, and it would be it would alternatively provide this 0.1 AU conditions for heliospheric model. So it is already coupled both to EUHFORIA and Icarus, and then an extended version is also being integrated, which has coconut, but inside we're propagating CMEs, which actually opens horizons to a new type of modeling. So to model CMEs already from low corona and also to implement some eruption scenarios. So this would be either embedded in a coconut or be directly coupled to EUHFORIA and Icarus. And then both of them, so the both coronal model and heliospheric model are coupled to extended Paradise model, the solar energetic particle model that is also being integrated. Because now, instead of only using the solar wind from heliospheric model, it can also use the data from low corona, where also quite big portion of particles get accelerated. And then the new the SAP visualization tool is of course added so that the users can also access this data. This would include the particle densities superposed on radial velocity and the time profile intensities and anisotropies. So as you can see here in this very big and maybe somewhat in the middle confusing diagram, it is only to make life a bit easier for the modelers. So this will provide improved space weather modeling forecasts with better chains and more realistic models standalone. Then with this update in Space Weather Modeling Center, we'll be able to study SEP events due to complex CME interactions, and then What is also very important about Virtual Space Weather Modeling Center is that it is open source, so it is available to everybody, and everybody can freely use it. So here I would like to sum up the topic. So at the beginning, I introduced you with some background of space weather modeling and what each model separately does or stand for. So we model with EUHFORIA, we model the environment from Sun to Earth. And then Virtual Space Weather Modeling Center is the platform that integrates these different tools, which is available from eScience Center, as indicated in the instructions, as I believe you already all found. And since 2022, it as Virtual Space Weather Modeling Center included 15 more operational models, and then more different type of couplings and chains became available in different combinations. And also it is being updated so that the GUI is always very user-friendly and as easy as possible and as functional as possible for users. And apart from only GUI interface, the simulations are also requested via scripting, so via command line, and more models and model couplings, which is also very important, are being added and integrated in the Virtual Space Weather Modeling Center. With this, I would like to thank you. Here are some references for the papers with this description of different models and how chains are coupled to each other. So feel free to check it out, or the website itself, because I think it's quite explanatory. So thank you very much, and you can ask me any questions if you have any time. Thank you.
Very good presentation and very, very impressive tools. There is anyone that want to ask something?
We have good 10 minutes for the,
we
questions.
have almost 10 minutes before next talk. Any questions? If I may, I have a curiosity just about if you have any idea, any statistics about how many people, researchers, are using this tool, this virtual environment.
Yes. I had a slide about it actually, and I removed it because I thought it would be too much. I can check the numbers exactly, but not mostly, yeah. But I mean, it was explanatory. But mostly, it's most percentage is used still by command line because these operational runs are done. And I think in 2020 it had 20,000, but hits of it. I will check it and just let you know, or maybe introduce it later with the presentation of my group to be sure. But I'll check it. Yeah.
Thank you.
That's strong.
Yeah, I had a question on two questions actually. You wrote geoeffective KP and DST.
I meant indices.
So when you're estimating the indices, does that mean that you have the direction of BZ?
Yes.
Okay.
Yes. So it is of course calculated by BZ.
And so the second question is then, so 2 slides back, here you in the green, that's the upgrade, I suppose.
Yes.
And so here I see comparison with Omni data.
Yeah.
Do you have planned comparisons all along the chain wherever possible, or just at the end, Omni and ACE data?
Can you? What do you mean exactly? Where?
Will you also compare directly with measured DST, with measured KP, with measured any spacecraft in the heliosphere that is measuring something somewhere else?
It is definitely possible. It just has to be requested, the need for it. So if that is necessary, it can be definitely added, because it is still also the upgrades and everything that we're doing with Virtual Space Weather Modeling Center also so far is according to needs. So that can also be integrated and added. But currently, I think what is planned, like direct upgrade, would be with the Omni or ACE data at L1. But since with the new missions and new satellites, all these comparisons can be done and provided automatically.
Any other question? Ivan, please.
Yeah, the question is about the
registration of your configurations of different models in PITHIA eScience Center. Given the quite a significant amount of various options, are you willing to register every one of them as a separate data collection with explanation what components are used as a computational capabilities and all the input parameters that you require in order for the whole chain, and do it for a number of established configurations of all this computational run, so that single link would get it for execution to you?
Just to double check if I understand it correctly, by to register as separate data collections, you mean so that each tool, so each chain, so for example, EUHFORIA heliosphere is registered as a data collection, or what do you mean? Because all of them, all these tools that are available in the different chains or separately that you can do, have their descriptions of the input parameters in the standardized system, so that you can give the input parameters or upload your file or use the output of the other one. But I don't exactly understand what you mean by using one link.
Maybe Ivan was referring about the eScience Center integration description of this model.
eScience Center, yes.
In the PITHIA Center.
PITHIA.
So not only, okay, now I understand, because in eScience Center, you can find EUHFORIA, and then you go to Virtual Space Weather Modeling Center. That is how EUHFORIA and all these chains are integrated in PITHIA eScience Center. And also I saw that there is one model, for example, separately, the talk that Vivian will be talking next, that you can directly access from eScience Center, but it also takes you to Virtual Space Weather Modeling Center. So I think it is a matter of interest if all of these different tools are interesting to be directly available from eScience Center, or it is there are several that are more popular, like the other one, or EUHFORIA, and that takes there. So it is, I think, a matter of how interesting it is for the users to have separate access, or they just go from one and then have access to every one of them separately.
Right. If you register all the different combinations and each sub-model in the chain as a separate something, I'm not sure yet something is the data collections or the process or the computation, you get the advantage of data discovery. If someone looks for magnetopole's location, which was one of your slides, and you only register the final step of the whole chain of computation, that particular module will not be discovered by a user who was looking for magnetopole's location. So I would at least suggest that all these individual boxes.
That is true, yes.
Right.
That's also what I was thinking, because you only go to Virtual Space Weather Modeling Center if you're interested in space weather modeling, and then if you're looking for that and you go from there, then you discover all these different tools, but not individually. So that, yes, I think it shouldn't take more effort or more linking. I'm just thinking from the integration point of view. It's just how many different things take you to the same platform. So I guess it can be discussed that more models are directly available, because they can be run as standalone models.
I would certainly advocate for that, just for the sake of data discovery, because you never know which components may stir interest of especially an uninitiated scientist who was looking for some corona, for example, or something.
Yes. If you start from eScience Center, it can be definitely improved.
It's certainly more work. That's granted.
Anyone else? We have 4 minutes. We have 4 minutes in advance yet.
Sweet.
Okay. Let's thank Tinatin again.
Thank you.